Hi there, and welcome back to the next module in the AI Developer Bootcamp. My name is James, and in this session we're going to be looking at how to use Microsoft Cognitive Services to understand human speech. But before we get into it, we're going to define a couple of terms that you're going to hear several times in this session. The first one is speech to text, or STT. This is taking a recording of a human voice and turning it into text. The reverse is called text to speech, or TTS. And this is taking text and generating a synthetic voice for playback to a user. The cognitive services that we're going to talk about today are quite interesting because they actually already power some of Microsoft's biggest voice-powered services, including Cortana, Skype, and Xbox. So, as we saw in the very first module, speech is an important part of the Litware Insurance demo. This is what allows us to speak to the bot and for the bot to speak back to us. So that's going to be the first question we try and answer in this session. How do we interact with our users using speech rather than just text? The other capability that we saw in the Litware demo was that we were able to recognize our users' voices as part of an authentication challenge. So we're going to figure out how to do that using cognitive services as well. There are 4 services in the speech family in the Microsoft Cognitive Services platform. And 3 of them have some overlapping functionality. And those 3 are Bing Speech, Translator Speech, and Custom Speech, because they all have capabilities that enable speech to text. And one of the goals of today's session is to help you understand which one to use when. The last service is speaker recognition, which doesn't provide any speech-to-text service, but helps us to identify and verify the identity of the people speaking in recordings. So let's start with Bing Speech. Bing Speech is Microsoft's general-purpose text-to-speech and speech-to-text engine. It supports a substantial number of languages, and it has a number of features that makes it easy to get started with. It has cross-platform SDKs and easy-to-use APIs. It is low latency, so it enables real-time or near real-time translations from your users. It also enables us to select one of many different synthetic voices, so you can customize the experiences your user receives. This is by far the quickest way to get up and running with speech-to-text and text-to-speech. And you get to take advantage of the models that already exist that power services like Cortana. The bot framework also supports this natively. If you use the web chat component, you can automatically hook into this service and allow your users to speak to your bots rather than just type. Before you can get up and running using Bing Speech, you have to make a decision on the kind of model that you're going to use for speech recognition, that is speech to text. There's one of 3 choices that you have to make, and it'll depend on the application you're building. The first mode is called interactive, and this is ideal for many application scenarios where your users are issuing you commands. These are typically short phrases that are spoken. The next mode is dictation. So this is long, slightly more formal sentences where a user is recording something for transcription to text. The final mode is conversation, and this is a new mode that's recently been added and doesn't support as many languages as the previous 2. However, it's ideal for transcribing conversations between people, where the language is slightly less formal and is a mixture between short and long sentences. For example, recording and transcribing a meeting. Working with the REST endpoint is very straightforward. You take your audio sample, you post it up, and you receive back the transcribed text. However, if you are able to use the WebSockets API, you get a number of enhanced features, and it's the WebSockets API that underpins the SDK. So if you choose to use one of the SDKs, you'll get these out of the box. The first thing that the WebSockets API is able to do is it's able to transcribe a much longer period of recording, up to 10 minutes. The other capability that it provides you as an application developer is to be able to build experiences like Siri, Cortana, or Google Now, where it actually shows you partial translations as you are speaking into the system. You might be familiar with this. You start speaking, the words start appearing, and as you continue to speak, sometimes it will correct its original transcription. All of that kind of functionality is available if you're able to build on top of the WebSockets API. So, how do we interact with it? Well, if we do decide to use the REST API, there's a couple of gotchas to be aware of. You need to be able to specify the locale that the language is recording is spoken in. You need to be able to set a couple of flags here. You need to be able to set the content type and to enable chunked encoding for transfer. However, beyond that, it's just posting up your audio recording. If you decide to use one of the SDKs, make sure you pick the right one. There are actually separate SDKs for both the client, so that is when you're building client-side apps, and also the server, so when you're building service apps. If you pick the wrong SDK, chances are the performance that you get is going to be nowhere near what you expect. The client SDK is named after projects Oxford and NuGet, while the server SDK is named after Bing Speech in NuGet. So it's quite easy to get them mixed up. In both cases, the API pattern is a little bit different to what we would typically expect. Actually calling send audio or recognize doesn't return any text. To get the text or the partial responses, then we need to subscribe to events, as you can see in the two code samples on screen now. But once we have overcome that slight complicating factor, we're ready to work with the Bing Speech API. So that's Bing Speech. It's a general purpose speech-to-text and text-to-speech engine that's really easy to get started with. The next service we're going to talk about is Speech Translator. And as the name might suggest to you, this is a way of taking a recording of somebody speaking in one language and turning it into another language. And this service can output either text or, optionally, a synthetic voice in another language. So this is optimized for conversations and is designed to enable services like Skype Translator, which enables conversations between people speaking in different languages. Because it is an advanced set of functionality, it does support a few less languages than the mainstream Bing Speech or Text Translator. But it supports many of the same features, like WebSockets connections and partial results. Let's take a look under the covers and see how they managed to provide this service. There are a number of stages between recording somebody's speech and then being able to translate that and output a synthetic voice speaking the same message in another language. The first thing that it does is remove any disfluency through a technology called TrueText. People very rarely speak clearly and precisely. They can often repeat themselves, and a purely automated speech recognition model may not correctly identify the words. So before translating, the service can clean up the recorded text. And there are a number of steps here in TrueText text correction. So it takes the raw speech recognition output, it removes disfluency, it rescores and repredicts what words are likely to be, it applies segmentation, punctuation, and correct casing. And then it passes this clean recording, this clean output to the translation engine, which results in a much better translation and a much better outcome for our customers. Once we have this clean recording, we can then pass it through machine translation. And then optionally, we can push it back through text-to-speech to generate a synthetic output of that message. So let's go and have a look at that in action. Let's go and have a look at how we can apply speech-to-text and text-to-speech in our insurance bot. So in this demo, we're going to show you how easy it is to add both speech-to-text and text-to-speech functionality to your application. Now, keep in mind, if you use the out-of-the-box web chat component that's available with the bot framework, you can actually use its inbuilt speech-to-text capabilities. All you need to do is provide it with an API key for Bing Speech. Now, the Litware demo actually has an entirely custom front end, so we're going to have to do things slightly differently. Our front end attaches the audio recording to the message that it sends to the bot framework. So when the message arrives in our code, the first thing we're going to need to do is download it and then pass it on to the Bing Speech API to turn it from speech into text. Let's take a look at how that works. Before we call into our dialogue, we call this process audio method. That allows us to take the audio recording, translate it into text, and then put that text into the activity. That means that the Lewis dialogue can run against text rather than audio. Let's drill into that and have a look. The speech recognition API requires two key things. One, the speech sample, but also the language that it needs to recognize. It doesn't have a language detection function, so we need to be able to establish the language in which the user is speaking ahead of time. Here we can see the use of the server-side SDK for speech. This is just like the code snippet we saw in the slides just a few moments ago. So the first thing we do in this code is download the speech sample. The bot framework message that we receive has a link to that attachment. So we download it and then we can pass it to the speech recognition API. And you'll notice, as we talked about in the slides, that we subscribe to receive the final result. And that's that line here, subscribe to recognition result. We also subscribe to partial results. Now, because we don't implement any kind of WebSockets or real-time API, we don't actually have anywhere to visualize in the front end these real-time results, but we will log them out so you can see what this capability looks like. So let's have a look at this in action. Put a breakpoint there. Remove that breakpoint and kick off our bot service. We'll give that just a few moments to start up and return to the bot framework site. We'll reload that. And wait for our bot to come alive. It can take a few seconds because this is running on a couple of different virtual machines. Right, our bot has responded, it's ready to go. So I'm going to speak to the bot now. I need insurance. So that message is recorded within the browser and then uploaded to the bot framework as a binary attachment. The message is then passed along to my service as a URL. It can then fetch that message from the URL and turn it into text. So let's see how it's going. We can see that the breakpoint here has been hit. We can see that the final recognition result is I need insurance, exactly right. And then we can have a look at the debug output and we can actually see the partial results as I was speaking, as it was starting to process the record. So the service thought I was about to say and, but it turns out I was about to say insurance, so it removed that and replaced it with the correct term. So now that this has been completely recognized, we can pass this along. It will then go to Lewis as text rather than audio, and the remainder of the bot workflow will behave as expected. Now, the other thing that we need to consider here, and it's a little bit like the translator API, is that we also need to generate the output voice. When we speak to our bot, we expect that our bot will speak back to us. And we're going to do it in exactly the same place. We're going to do it as part of the custom prompter. We're going to attach the synthetic audio to the message that we send back to the client. So let's open that up and see how that works. So I have a breakpoint here, and basically if we spoke to the bot, then we should return an attachment with a synthetic audio recording. So let's continue debugging. This now gets translated, it goes through all of the other steps in the bot workflow. Lewis has now identified it, We've responded with the what type of insurance carousel that we need. We're now going to go and generate that text-to-speech attachment. We're going to drill in and have a look at how that specifically works. We'll grab the language that we're currently speaking. And then we're going to drill into the text-to-speech class. Now this is a service class that we've built. There isn't an equivalent SDK for the other part of the translation, that is going from text to speech. There's only an SDK for speech to text. Fortunately, the work that's required to call the text-to-speech engine is pretty lightweight. We need a couple of things in order to be able to call this engine. The first thing we need to do is decide which synthetic voice we're going to use. And each language has different voices available. And these are all documented. So here we've encoded all of these. So depending on the gender that we want for our bot, we select one of the available voices. Now, not all locales have a choice in gender. Some of them only have one option. So we select the voice that we want to use, and then we pass it an XML snippet. We pass an XML snippet that describes what we want the bot to say. We specify which voice to use, but because this is SSML, or speech synthesis markup language, we can actually get quite specific about exactly how the synthetic voice is generated. So we can enable specific words to be emphasized. We can tell it about proper nouns and names. We can actually control exactly how various parts are pronounced. But in this case, we're not going to do any of that. All we're going to do is pass the text that we got back from our form flow and have that turned into a synthetic voice. First off, we're going to remove any formatting tags that we might have included. We're going to prepare the request. We post that up. And we get back a byte array. And that byte array is then sent back to the client. And our client is smart enough to take that and play it through the browser.
What kind of insurance are you looking for today?
So as you can see, we've spoken to the bot. It's been able to process that through speech to text. And then before responding to us, it's been able to attach an audio text-to-speech that we can then play in the browser. So now we can speak to the bot just as we would speak to an agent. And with that, let's get back to the slides. The final service that provides speech-to-text capabilities in the Microsoft Cognitive Services platform is the custom speech engine. And as we mentioned at the very beginning of this webinar, we can use the custom speech engine to upload our own recordings of users speaking and example phrases to actually improve the recognition accuracy of the model. Let's take a look at what's involved in this. First, we select a base model. We can select a model that Microsoft has already prepared that's tuned either towards dictation or conversation. So we don't have to train this with every known word and every known way of using the English language. We get out of the box a service that is equivalent to Bing Speech. We can then upload a bunch of language samples. So these are just examples of utterances that may be expressed to your application. So they can be very domain specific. Next, optionally, we can record our users interacting with our application and upload these to improve recognition accuracy as well. This helps resolve issues like users that may have a slight accent or potentially users that are in an unusual acoustic environment. For example, your application may typically be used in the car, which echoes and has road noise, or potentially in a factory, which has background noise. So recordings of the users actually using your application in this scenario can be uploaded and used to improve the model. And finally, if you have any particular acronyms that your organization uses, you can upload these as well and train the model to recognize them. One of the most exciting parts about this capability is that it's API and SDK compatible with the Bing speech engine. So if you start off your speech-to-text voice recognition journey with the Bing speech engine and then get to a point where you need to customize the model and make it more suitable for your applications, then you can switch over to the custom speech engine simply by updating the URLs and the keys that you use. The rest of your code remains unchanged. Right now, this is still in preview, so the number of languages that it supports is limited to English, Chinese, and German. One thing to point out that's important is that because it's in preview, Microsoft reserves the right to retain some of the data that you submit for their own testing purposes. You can opt out to this, but it will cost you a little bit more in the preview phase. So what's involved in setting up one of these custom speech models? First, you need to record all of the acoustic samples that you want to use to train the model to work around accents or weird acoustic environments. This is an optional step. If you are unable to record users, then you can still gain from the custom speech service. The other thing you'll need to do is accumulate all the different things that your users might say to your application. Now, keep in mind that you're building on an existing speech-to-text model, so you don't have to completely redefine every potential thing that they could possibly say, because it can fall back to the standard model to process that. So once you have your data, you upload this to the custom speech portal, and then you select your data sets and train a new model. Now, one of the really cool features that's part of the custom speech service is that you can actually evaluate the accuracy of this new model within the portal. If you upload additional data, you can run this through this new model. You can run acoustic samples through this new model, and it can identify the word error rate for you. This helps you iterate and ensure that each new model is actually better than the last. And then finally, once you're satisfied with the performance of your model, you can publish it as a set of endpoints. As we already mentioned, these are API compatible with the ones that are used by Bing Speech, which makes it really easy to connect to an existing application. If we revisit how we integrate with a speech-text service, you'll notice that the code that we need to use is exactly the same as what we used when we integrated with Bing Speech. In this case, all we needed to change was our authorization header and the URL that we were sending messages to. Similarly, when we're using the SDKs, we need to update both the service URL and the authentication URL. The remainder of the code is unchanged and will work in exactly the same way. Let's have a look now at the custom speech service in detail and see how we can set up our own model to improve the recognition accuracy in the Letware bot scenario. So if we want to use the custom speech service, we need to go to the portal, and the portal URL is cris.ai, C-R-I-S.ai, and that's the old name for the custom speech service. It used to be called the Custom Recognition Intelligence Service, and hence why it's got this slightly odd URL. So when we sign into the CRIS portal, the most important part is getting your subscription key registered. Now, you'll need to get a subscription key from the Azure portal, and if you haven't got one already, you'll be prompted to insert it before you can go any further. And getting a subscription key is just like provisioning any other cognitive service. Go to the new option in the Azure portal, search for the service you're interested in, and then provide it a name. So I've already set mine up, so I'm ready to go. Now, all of the important steps that you'll need to follow to build your own custom speech service are in this menu at the top here. And there are really 5 steps that we need to follow to build a custom speech model. The first one is the data. So we can upload acoustic recordings of our users in their various environments with their various accents. All we need to do there is zip up a bunch of WAV files and then provide transcripts of what these users are supposed to be saying. From the same page, we can also upload language data sets. So these are examples of the kinds of things that your users are going to say to your applications. We can also upload here any acronyms that may be worth including to enhance the model further. So once we've uploaded all our data, we can start building models. So from the acoustic models page, we can build, as you might expect, models based on the acoustic data, the recordings that we've provided. And building acoustic models is pretty straightforward. The one thing to make sure that you keep an eye out for is the base model that you choose. Like all of the custom services, Microsoft provides you a model to build on top of. We don't have to build a model from scratch that completely understands every aspect of the English language. So we can choose a conversational model, which is ideal for people talking to each other, or a search and dictation model, which is ideal for short commands that we might be giving to an application. The other nice feature here that we mentioned in the slides is that we can enable accuracy testing. So we can select a data set that we want to run through this new model, and we can understand its performance. The next option is creating language models. This is based on the example utterances. And then finally, we create a deployment. And that's really just selecting the acoustic model that we want to use and the language model that we want to use. And remember, these are optional. We can just use an acoustic model, we can just use a custom language model, or we can use both. Once we've created a deployment, we get a set of new URLs. So our service has a unique URL and a subscription key that we've fetched from the Azure portal. And we're now ready to integrate this into our application. So what happens? How do we do that? Well, if we switch back to the Litware Insurance demo and we return to where we translated our audio recording into text, the only thing that we need to change here is the URL and the subscription key and the token endpoint, right? So this is where we get the token from. All of these URLs are available from the custom speech portal. The rest of the SDK doesn't change at all. It's exactly the same code, but instead of using the general purpose Bing model, we're now using our own custom model. Now, to show you this in action, to show you the power of this particular technology, I want to bring up an application that simulates somebody speaking to a kiosk in an airport. So let's play a sample here and see the performance of the general purpose Bing speech model versus the performance of the custom speech model. So the custom speech model in this case has been trained with examples of people speaking in an airport. So there's background noise, there are PA announcements going on. It's customized to this particular acoustic environment. And it's also been trained with the kind of language that you might expect when inquiring about airlines.
Show me all flights from Pittsburgh to Boston, both direct and connecting, that depart Pittsburgh after 7 p.m.
So there's a couple of things to note here. First, we're getting partial results as they're being processed. And that's available through exactly the same SDK service for both Bing Speech and the custom speech service. The next thing is pretty obvious as well, is that the recognition accuracy of the custom model tuned to the airport acoustic environment and terminology is far superior to what is available through the base Bing speech model. And with that example, I think we'll get back to the slides. So now we've seen the various capabilities for speech to text in the Microsoft Cognitive Services platform. We saw the general purpose Bing Speech API. We saw the Speech Translator API, which added translation capabilities. And we saw the Custom Speech API, which allowed us to build our own models with language data and acoustic samples. It's now time to move on to the Speaker Recognition API. And it's the Speaker Recognition API that was able to help authenticate me in the Litware Insurance demo. The Speaker Recognition API requires a little bit of setup. It requires you to train the API to recognize users before you can go and call either the identification or the verification endpoints. The identification service that it provides allows you to provide it a recording and it will tell you who is speaking. And this is ideal, for example, when you're transcribing a meeting. It can identify who is speaking at any one time, and then you can pass that sample off to a speech detection engine. The other service that it provides is verification. And in this case, the user has to say a specific authentication phrase, and then the service can identify whether it's the same person that you expect it to be. And we saw this in the Litware demo. when I said, "My voice is my passport, verify me." Right now, the service only supports English and Chinese. It's available via a RESTful API or SDKs for Windows or Android. It's important to call out when we start talking about verification that it is not a substitute for a password or a proper second factor like a thumbprint. All we're doing here is comparing a recording of the user to the profile that we have. There's nothing stopping you from recording one of your colleagues saying their authentication phrase and simply playing it back. That will work and be correctly identified as your colleague. So what's involved with getting started with the speaker recognition API? Well, first you need to create a profile to represent the user that you want this API to be able to recognize, either identify or verify. You then need to enroll this user. So for identification purposes, you just need to send a snippet of them speaking between 30 seconds and 5 minutes. For verification, they need to say the specific verification phrase that they have spoken 3 times to create that enrollment. Once that's complete, you can start recognizing them. In the identification scenario, we just need to submit an audio sample, but we also need to submit a list of potential people that could be talking. We can't just get it to search every single profile. We need to give it a list. For verification, we need to specify who we think it is and the recording phrase, and it will tell us whether that person is in fact in the recording. Let's go and have a look at how speaker verification works in a little bit more detail in the Litware demo. So let's return to the Litware insurance demo and see the speaker verification service in action. So the speaker verification service has an SDK that we can get started with really quickly. And there are 3 key steps, as we saw in the slides, to successfully use the verification operation. First, we need to register the person. Then we need to enroll the person by repeating the authentication phrase several times. And at that point, we can then verify a new recording. So let's see this in action. We'll kick up our bot. And return to the website. Let's just refresh the page here and make sure we're up and running before we go any further. Great, so the bot is responding. We're going to use a training interface for the remainder of this demo. So let me open that up. And I want to enroll for the first time with the speaker verification service. Now, I'm going to use the phrase, "My voice is my passport, verify me," but there are actually a number of different phrases that you can use. So let's do the first enrollment activity. "My voice is my passport, verify me." So if we switch back to the code, we can see because I don't have a profile currently, the first thing we're going to do is create a profile. Note that there are no mentions here of the recording that we've just captured. The recording is then immediately enrolled against that particular profile. We're now being prompted to enroll again. "My voice is my passport, verify me." We hit the enroll breakpoint again, and if we step through just slightly, we can actually see the enrollment response. And the enrollment response tells us how many more times that the service would like us to record that phrase. Or it will also tell us if that particular recording was not suitable for an enrollment. And finally, one last time, "My voice is my passport, verify me." We get a breakpoint again during enrollment. And now it's time to verify. So to show that this is in fact real, I'm going to say something else. Obviously I can't change my voice, but I can change the phrase that I speak. 1, 2, 3, 4. We now hit this verification step. We pass the profile and the raw audio recording. And let's pass that up and see what it says. The result in this case is a rejection, and we can render that in our front end. So we get a big red line through the microphone. Let's try that one more time. My voice is my passport, verify me. Here, we do exactly the same thing. We pass that up to the verification API, but in this case, we get back a different result. We get an acceptance that service is confident that I am in fact who I say that I am. And with that, let's get back to the next part of the slides. So we just saw how we can use speaker verification, which is part of the speaker recognition API in the cognitive services platform. It helped us verify my identity when I spoke the required authentication phrase. As we mentioned at the start of the session, a lot of the services in this particular area of the cognitive services platform are actually powering some of Microsoft's most innovative services. Let's take a quick look at these, because you as a developer can take advantage of the same services and provide similar experiences to your customers. The first innovative experience that Microsoft has been showing recently is the Skype Universal Translator. This allows me to connect to a meeting, speak or type in whatever language that I want, and then other participants can receive my text messages in whatever language that they want, or hear me speak in whatever language they want via a synthetic voice. We're going to see this in just a moment. The other recent announcement from Microsoft in this space is Presentation Translator. This actually relies on the custom speech engine, which is now available to us as developers. The plugin for PowerPoint submits the content that's contained within your PowerPoint slides to the custom speech service and builds a custom model. It then uses that custom model to recognize as you are speaking in your presentation and provides live subtitling. The custom speech model is particularly useful here because presentations tend to contain a lot of domain-specific terminology. And by using custom speech, we can build a more accurate speech recognition model than Bing Speech alone. So let's go and have a look at the Presentation Translator now and how it can help you give better presentations, but also as an illustration of the underlying translator speech API. So now let's have a look at some of the technologies that Microsoft have recently released based on the cognitive services. The first one I'd like to show you is the translator. In this case, I've logged in on my laptop as a French-speaking user, and on my mobile device, I've logged in as an English-speaking actor. So here, I'm going to speak into my phone, and we're going to see it pop up on the screen in another language. My name is James, and I'm a software developer. So as you can see,
Je m'appelle James et je suis développeur de logiciels.
So as you can see, there is a partial translation. As I start to speak, we see it immediately in real time appear in the chat room. In addition to that partial translation, it generates a synthetic voice. So I can actually listen to this and not just read it. So this is an incredibly powerful technology. I can speak or type into my mobile device in English, and then another user can read my comments or even listen to me in another language. So that's the first of the two technologies that Microsoft have been innovating in with translation. The other technology is a plugin for PowerPoint that we just mentioned called Presentation Translator. The slide that I have here on screen has a whole bunch of really quite complex words. And you'll notice that I'm using PowerPoint for Windows. This is not yet available for Mac. So we're going to go to the slideshow tab and we're going to click Start Subtitles. And this is actually going to generate the custom speech model that understands these terms and is going to provide a better subtitle experience for my slideshow. So let's start this up. I have to make a couple of small selections here. I have to say what language I'm going to be speaking and the default subtitle language. Now this does actually allow users to join in other languages if they want to read along on their mobile devices. Now this takes a moment to start. Today we're going to be talking about cognitive services. The biomimetic approach of the Fujianese frog is amazing. I live in Auckland, New Zealand. So as you can see, the ability of the presentation translator combined with the custom speech model enables highly accurate real-time subtitling of presentations. Let's get back to the slides. So we just saw an example of how Microsoft is using these technologies to deliver new experiences for their customers, and these technologies are available to you today. So which APIs in the speech family should you use in your application? Well, the best place to get started is the Bing Speech API. It is a general purpose speech-to-text and text-to-speech engine. It has broad language support and excellent SDK options, which make integrating it very straightforward. As your application develops, you might look at the speaker recognition API as well. Keep in mind this does require some training because it needs to be able to build profiles of the people that you wish to identify. You might also look at speech translator if you have a requirement to have a multilingual voice-based aspect to your application. And then finally, in the advanced category, is custom speech. And I should point out at this point, it's really not that advanced. You can simply upload a whole bunch of language data that is sample things that your users might say to your application, and already you're going to get a better language model and a better speech-to-text experience. However, providing acoustic data, that is recordings of your users using your application in the real world, can be a little bit more complex to set up, and therefore we've placed this in the advanced bucket. So that brings us to the end of our session on speech. We've answered the questions that we set out to. We've identified how we can interact with our customers using speech, either using a general purpose model like Bing Speech, or using a customized model available through the custom speech service. We've also identified how in the Litware insurance demo we were able to verify our identity using our voice, and that's using the speaker recognition API and its verification functionality. I hope you'll join us for the next session in the AI Developer Bootcamp when we look at Microsoft's Vision APIs.